Hello everyone, welcome to this class on finite element analysis. And in this class, let's study a problem that is already we have studied. A problem that is much similar to this. That is, it's going to be the same question, but only one change is we are going to study. Determine the nodal temperature distribution by penalty method. That is the only difference. So penalty method is the only change here. That is already we have studied the same problem. I think the problem number one in composite walls. So three elements with K1, K2, K3 values, H value, T infinity, A is unit area. Therefore, lengths of elements are also given. So for this, every only change that what we are finding in this problem is by penalty method. So we have done that problem by using elimination method. Here we are going to use, do the same by using penalty method. So this is just going to be a short video where I have already solved the solution. So you can just, just check out once. Check out that video for the this understanding of this SI units, all that. It's the problem number one which I have solved. You can just check out that video. Here I'll just tell you in short. So all this K1 values, K2, K3, that is the thermal conductivity is given, H heat transfer coefficient is given. It's happening on the left hand side or on the innermost surface. T infinity is the ambient temperature or surrounding temperature. A is unit area. Even though if it is not given, we are going to assume it like that. Then L1, L2, L3 values are also given. So the FEA model is written like that. As there are three elements, you're going to write four nodes. Elemental stiffness matrix for convection is K1, K2, K3. I think you know that well. So this also we have solved it using the last problems itself. So K1 is thermal conductivity. A is A1, area A1 is 1 and length L1. So that's all given. Stiffness matrix due to convection. When it's happening on the left hand side, it's going to be 1, 0, 0, 0. And area A is 130. So when you're multiplying it inside, you're going to get that. So I don't want to just elaborate this too much because the same problem is there in the last previous videos. Only change is penalty method. Only that I wanted to emphasize here. So let me just go to the next page. So here you are going to write that force vector. So force vector is AHT infinity. As it's happening on the left hand side, it's going to be like that. Then you're going to write the equilibrium equation. So before equilibrium equation, you're going to write the global conduction matrix. This is going to be the global conduction matrix. So similarly, this is going to be the global convection matrix. So both you're going to add here the combined matrix. So 50 plus 30 is going to be 80. Apart from that, all other elements are going to be the same, whatever you got here. So that you're going to represent here. So in this, what is in this equilibrium equation, you're going to get it like this: K plus H, the whole multiplied by T, which is equal to F. So you're going to get it like that. So this is going to be K, this is going to K plus H, and this is T, that is equal to F. So this one into T equal to F. So you've got it like that. So F is nothing but all this, you would have got it. So on the other nodes, on the other two nodes, you can directly write it 0. So now only change, as I told, here we are going to use penalty method. That is the only change. So penalty method, see, in the previous two videos, we have solved the problem based on elimination method. So this is the only change here, penalty method. Understand clearly this, we are solving by penalty method. In the exams, they may ask sometimes determine the nodal temperature distribution by penalty method. So understand that very well. So for penalty method, you have to take this formula: C equal to maximum of Kij into 10 power 4. That is equal to, you can just see maximum of Kij, in the sense, you see in this K plus H, you will have to determine the, in this final matrix, you have to determine the maximum element. So in this maximum element is, see, it is mentioned as modulus. That is any number irrespective of sign, irrespective of plus or minus, that's what you have to take. And here you can clearly see 425 is the maximum number. So 425 multiplied with 10 power 4. 10 power 4 is a standard, it's a formula. So 425 into 10 power 4. So where do you have to add this 425 into 10 power 4? That is the question. Now you can just see in this question, T4 is given, that is T naught or the outermost surface, or T naught is equal to 20 degrees Celsius, or T4 equal to 20 degrees Celsius. That is given. So when that is given, here you are going to add, that is, as the fourth nodal temperature is given, you have to add to 4 cross 4, that is fourth row and fourth column, that one element with 4, 4. There you have to add it. So that one I'll just show you in this matrix here clearly. So this is the fourth row. So this is the fourth row. This is the fourth column. Fourth row and fourth column, one element means it is this one. Fourth row and fourth column, that one element. To this element you have to add. That's what they have mentioned here. Kij. Ij means 44. Fourth row and fourth column. Fourth row and fourth column, this is the only element. So only element at fourth row and fourth column. To this element you have to add this number. Apart from that, you have to add this in F4 as well. F4, whatever the number is there already here, you have to add that number there as well. That is the only two changes that you are going to make here. So I've just done the change over here. You can just see in this page. So this is the K plus H matrix. So here in 4 cross 4, I'm going to add that 425 to 10 power 4. Already the element that was present there was 275. So 425 into 10 power 4 plus 275. When you're adding it, you're going to get it like this, something like this. You're going to get something like 4.250275 into 10 power 6. So then all in here it was 0. So 0 plus this is going to be the same. Now after this, you're not going to eliminate any row or column because this problem is based on a penalty method. So as T4 is given, solve for the other T3 temperatures. That's what is the question. You can directly start doing the multiplication. So 80 into T1 minus 50 into T2, 0 into T3, 0 into T4. So let me try to write the first four equations. Minus 50 into T1, 200 into T2, minus 150 into T3, 0 into T4. Next 0 into T1 minus 150 into T2, 425 into T3 minus 275 into T4. Next 0 into T1, 0 into T2 minus 275 into T3, 4.20275 into T6 into T power 4. So that is equal to these four numbers. So 27,000 and here it should have been not this one. So here it should have been 425 into 10 power 4. But still that's not going to matter because we are not going to consider this as well. So now what we have to do is, we have to substitute these values of T4 equal to 20 degrees Celsius in all these four equations. When you are substituting it, you are going to get 80 T1 minus 50 T2 plus 0 T3. So it's plus 0 T4, plus 0 T4, 0 into this is going to be 0 only. Directly whatever is there on the right hand side, you are going to write it. Next here, when you do also in the second equation also, you are getting 0 T4. 0 into T4 is going to be 0. Directly it's going to be 0. But here it's not like that. Minus 275 into, so here it is mentioned as 0 T1 minus 150 T2 plus 425 T3. That is equal, minus 275 T4, if you are sending it to the right hand side, it's going to be plus 275 T4. Plus 275 into T4, that is 20. 275 into 20 is going to be 5,500. Similarly, you can do for this fourth equation as well. You're going to get, but you're not going to consider this fourth equation. Let's not worry because we need only three unknowns. So three unknowns in the sense we can directly eliminate this. You don't have to consider this fourth equation at all. So you can just take your calculators, give the equation mode, number of unknowns, give it as 3. You can take this as A1, B1, C1, D1, A2, B2, C2, D2. A3, B3, C3 and D3. So upon solving, you're going to get the values of T1 as 439.04 degrees Celsius, T2 as 162.476 degrees Celsius, T3 as 70.28 degrees Celsius. You can observe like even in case of elimination method or in case of penalty method, the answers are going to remain the same. And as you know, the value of T4 is 20 degrees Celsius, and you can see the temperature is flowing from a region of higher, the heat is flowing from a region of higher temperature to a region of lower temperature. As the nodes are increasing, you can just see the temperatures are reducing. So clearly observe that this is the only change that you have in penalty method and elimination method. So observe that this is the only change, that penalty method you're going to add this. Apart from that, there is no any other change. I hope you understood this. Thank you.